piece of notes that you've got there. Last one ever. 13 minutes we've got left. Okay. All right. Volume of the region bounded by x equals 0, y equals the square root of x, and y equals 1 when revolved about the horizontal line. This one's not going to be a washer, I don't think. I don't know why. I put that one on the second. We may come back and do one, but let's skip the two. All right. Y equals x. Is just going to be this line here. Since y equals x, we have y equals 3. So that is the horizontal line at 3. And we got x equals 0, which is our y-axis. So we are looking at this region right here. And we are rotating around the line y equals 4. So this line right here is not a boundary. This is our line that we're rotating around. Okay? So you got it. The graph is going to be really important for this because you're going to have to use that to think about outside radius and inside radius. In this particular case, should we be doing everything in terms of x or in terms of y? X, because we have a horizontal line parallel to the x-axis. Everything is in terms of x. So our outside radius is going to be from the line we're rotating around to this function right here. So this is our capital R of x. All right, now here's what we got to think about. One way we can think about doing this is sort of like we were doing area. It's going to be top minus bottom, because when we have this equation right here, which is just x, that gives us this right here. So we don't want to do like x minus something in this case. Just think about when you're doing that capital R, think about doing top minus bottom. The top of this is that purple line, which was 4. The bottom of this is at x. So if you're thinking about it, the length right here is always 4 all the way across. The blue line, what's below it, is x. So it's going to be 4 minus x is going to give us that capital R. Does that make sense? You can think about just top minus bottom of whatever that line is. Okay, that's your capital R of x. This one is going to have a hole in the middle, right? So we are also going to have a lowercase r of x. Again, we can think top minus bottom. Or in this particular case, that one's the same all the way across, right? But if we're thinking top minus bottom, then we're going to be thinking 4 minus the bottom, which is 3, which, since this one's very simple, it's not a second curve, that's just 1. Okay, it's a lot like the other ones we were doing. It's just you got to think about the capital R of x and the lowercase r of x a little harder whenever you're doing this.
Here's what I found.
So we're thinking about the capital R of X and the lowercase r of X for this. So not really like the region that we're looking at, because we looked at, whenever we were looking at the region, it was a little bit different. But even on those other problems we were doing, if there is not a gap, we could still do top minus bottom. So like, let's say we were rotating around 3 right here, we could do like 3 minus X for our. Yes. You can. I already shut that one. No, I haven't shut it. Let me see. For this one, you can still do top minus bottom, because if you do top for this, that is the 4 minus x squared. That one's on top, and the bottom you're subtracting, but the bottom is a -5, so it's going to take care of itself where you're doing minus a negative where it becomes a positive. So you could still do like the top right here and the bottom right here. Remember, you're not rotating around the axis here. You're rotating around -5. So it's furthest away from the axis that you're rotating around. All right, let's go back over here. All right, so whenever we set this up, now that we got, if you can get your capital R and your lowercase r correct, it's just like we've been doing. It's the integral from, what should my limits be on this one? 0 to 3. Pi times 4 minus x squared dx minus the integral from 0 to 3 of pi times 1 squared dx. And if you want to write it all together, you don't have to, but integral from 0 to 3, pull the pi out front, you would have 4 minus x squared. Oh, make sure that square's on the outside of the parentheses. Minus 1 squared, which of course is just 1. You would put brackets around it and put the x right there. You can put the square here on that 1 or not. It doesn't matter, since 1 squared is 1. It would matter if it was a number besides 1. And we are only going to set up, because we don't have time for that one, so that we can look at one more. All right, real fast. Y equals 2 minus x. So 2 minus x will look like this. All right, we've got y equals 2 minus 2x. So 2 minus 2x. Same y-intercept, different slope. Oh boy. We've got some more. And, okay, this tells first quadrant. So we're just looking at this area right here. And we are rotating that around the line x equals 3. X equals 3 is going to be this line right here, x equals 3. Since that's vertical, everything has to be in terms of y. So y equals 2 minus x. So if we do y minus 2 equals negative x, which is 2 minus y equals x. So my blue line, this right here, is x equals 2 minus y. And my red line, y equals 2 minus 2x. Y minus 2 is is negative 2x, negative 1/2 y plus 1 equals x. I'm doing that kind of fast, but okay. All right, so this time we're thinking outside radius is going to be from the green line to the red line. That is our capital R of x. So capital R of x, you can think right minus left here. So right side of this, is that right? Yeah. It's 3, and the left is the red line, which is negative 1/2 y plus 1. Then we got to think inside radius. Here, lowercase. I should be using y's, not x's. So lowercase is the right side is 3. Left side is 2 minus y. And we're out of time. But you would just have pi times the integral from, it would be 0 to 2. Capital R of y squared minus lowercase r of y squared dy. Okay, I think these had assignments on, but we're going to do whatever's on Canvas. So, Canvas has 13C and D, 14C and D, 18, 20, 23, 24, 54. You are welcome to use your calculator to integrate any of those, even if they're simple, because my main concern is that you can set them up right. This should also be your last book homework. Probably. I don't usually give book homework after this, so